Hello, my name is Vadim Tynchenko. I am an associate professor in the Reshetnev University of Science and Technology, Krasnoyarsk, Russia. I would like to introduce you our work that's named Mathematical Modeling of Waveguide Paths by electron-beam welding. This work was done by 5 of our researchers in our research band. So the first is Sergei Kurashkin, the second is mine, the third is Yuri Serogin, the fourth is Alexander Murygin, and the fifth is Alexander Lavrishev. So let's start. The purpose of this work is conducting mathematical modeling of waveguide paths by electron-beam welding using previously developed functionality to search for technological parameters. This slide presents the formulas for calculating the temperature distribution. It is a fast-moving point source and a fast-moving linear source. The equation 3 describes the power model for our case. This slide presents the functional. A complex fast-moving source was selected as two sources, a combination of a point and a linear one, equivalent to real ones taking place in the literature. The functional value calculation is performed for an area whose dimensions are comparable to the penetration channel. This slide presents the functional plot against from energy variation and the integration time. On the graph, we determine the energy coordinate in which the functional undergoes an extreme value, its minimum. This time is further taken for calculations. This slide presents integration time plot of T against from energy variation, Q. This is necessary to evaluate the integration time correlation against from energy variation, which will help us to determine the optimal energy value. This slide presents a functional plot against from temperature variation. Using the obtained energy value and integration time, we construct the functional versus temperature. At this stage along the way, we calculate the limited heating zone width, which is the weld width equivalent. This parameter can be used to predict the seam width. At this stage along the way, we calculate the heating zone limited width, which is the welded joint width equivalent, YGRIC. This parameter can be used to predict the seam width in changes case in the welding technological modes, such as welding speed, welding current, changing focal length. This slide presents the results of our investigations. When we received the energy values, integration time, and boundaries for calculating the welding parameters using the functional extreme properties, we proceed to those parameters direct determination. This slide presents the results. In this work, the preliminary research was made with modes to obtain the weld stable quality in the waveguide paths electron-beam welding with 0.65 millimeters thickness and above. Thank you for your attention and goodbye.